Hello, welcome to another video of this Veldboom Studios YouTube channel. In this video, I will show you how I kind of redesigned the suspension wishbones, the wheel uprights for the front, to allow them to actually steer, but also use some like AI adaptability to topology optimization, I should say, to kind of make them as strong as possible as they need to be for the job they need to fulfill. So here you can see that I started with the original design, and I basically first needed to redesign everything so that the computer could calculate the shape that it needs to take instead of the design that I made for it. So I'm basically like deleting all of the changes that I made to the simple block, and now I kind of have like the simple block that the computer can calculate all the stresses through. So here I kind of maintain the same dimensions that I need to actually bolt it to the system that I have. But at the same time also removing the components where I need to have the space to actually bolt the suspension components to it. So those are like the shapes that I'm kind of maintaining, and I'm leaving the rest of the volume to kind of be calculated by the AI to kind of optimize the shape for the performance we needed to have. So here I'm kind of giving it the fillets and stuff to still be able to maintain it, and also kind of give it some extra geometry to kind of calculate the forces through. So basically maximize those to be able to allow the computer as much free space as possible. And here I'm making the ball joint for the steering connector as well, because I figured it might be good to actually, because that used to be a loose component, but I wanted to integrate it with the suspension component to make it just the least amount of components that I needed to have it. So that is kind of like the whole process of making sure that everything is just simplified and designed to the T. And if I'm kind of sounding like under the weather, I've been a little bit sick over the past couple of days, so that's also why I've been kind of slow to work on the car and everything, but I'm getting stronger now and I needed to rest up just a little bit more. But we're getting there. The final part, hopefully you can like hear the printers going in the back, so we're actually making the final components for the car. And the steering is damn near done, braking and all of that, so we're getting there. So here you can see like the final fillets to kind of round off the edges that I still needed for it, and also make sure that all of the holes are connected through for the bolts to kind of get in there. And then it's basically just letting the computer do the rest and making sure that all of the calculations are run through. So I need to like specify the material that is being used. And so for all the simulations, I kind of made sure that I had all of the correct specs and the forces that will be applied to all of the components and stuff. So the simulation was made for ABS. I will make it in PLA. So I bumped up like the forces necessary to kind of create the shape just a little bit more. And then that is kind of how I kind of came to the shape. So you can see from the center it is kind of rotating as a torque. So that is like the force applied to the braking and all of that, that it makes that it is capable of withstanding those. And then from the top and the bottom you can see that it's also being compressed. So those are like the suspension forces going through it. And then here it kind of made the first calculation, and I went through a couple of iterations, so you'll see me kind of changing those, and also adding some parameters of the limitations of the calculation. So now I kind of made the outline border of a material that it can't like skip out on. So it has to kind of maintain those shapes, and then you can kind of see that it is now attaching all of the screw patterns and everything. And now I did it one more time to actually also attach the steering arm to the wheel carrier, because that was showing up as like a loose component, because we also didn't really like apply a lot of forces through it, because that's just the steering arms and stuff. So the plastic will be fine to kind of deal with that. And now you can kind of see it come more alive with the shape that we kind of desire for it and require for it to kind of be powerful enough. And I think this would be then the last iteration to kind of ensure all of the shapes and everything it needs to get there. And then finally you will be able to see that this will then also be the component that we're 3D printing. So here we go with the actual calculations. You can see like it made a whole lot of like hollow bone-like structural natural, like maybe even a tree root system or something. It's a very organic looking shape that the computer will kind of come up with to deal with these forces and stuff. And then you can kind of see how nature works, through the component itself. And then through that we can create like a mesh component that is reflective of all of the surfaces that we now need. And I also show this cut through to also show you that it is also like printing with internal shapes to kind of make it hollow and strong in all of those points, where it doesn't need the material, and also as light as possible. And then for the final components, we just basically inspect everything to show that it is the way we need it to be. and then we're gonna go into the next stage where we actually start to also export this to then 3D printing files, you know, where we can actually like turn it into something, a sliced 3D mesh that is then also printable. And then what I'm here also looking for is the actual ball joint component to attach to that arm, because we need to 3D print those in place and kind of surrounding each other instead of assembling those afterwards. And that is kind of what I did here in this process, to just line it up with the rest of the component, but still making sure that it isn't actually coming into contact with it, so that it remains like two separate components instead of having them come in contact with each other, because then it would 3D print as one big whole thing, and we can't have that. So that is basically like this whole process, trying to figure out what the best way to print it would be. And then also I need to mirror this onto the next side to kind of be able to print it left and right. And here I'm kind of inspecting, especially with the ball joint section, whether it's actually like separate to the rest of the wheel carrier. So that is what you can kind of see to the left of the screen, where you can kind of see where it is with the ball joint section, where it's just two separate layers instead of them actually contacting with each other. And then from that point forward, we actually go, so I'm going to export this and take it through the 3D printers. And then for the next shot, you'll actually also see that that process starting up. I'm also working on ways to kind of mount cameras through my 3D printers, so that I can make, so here you can also see like the mirroring process to kind of get it from the left and right side. But I'm also working on 3D printed setups where I can actually mount the camera through the printer to make like cool time-lapse videos for the actual prints that you can see, you know. So that is kind of like what I try to mimic here in this video, but we're gonna get that a little bit better. Let me turn the audio off. So that is kind of like what we're gonna get into in the next stage, just to actually also make the video production a little bit better. But I think with this, you can kind of have a good idea of what the setup is and how the printers kind of turn out when they are up and running. And then that is just done on the Ender +5, those two components. And we have a couple of different 3D prints that we can also use it for. And here you can actually see them already on the car. So these 3D printed components are actually very strong. I put all of my max weight on it as I could, but it wasn't budging at all. And then you can also see the loose ball joints that are actually like the steering attachment arms that we can then attach to the rack and pinion system that we have on the car, to actually make sure that the steering will be fed through to the wheels and all of that. So you can also see some of those hollower shapes and everything within the 3D print as it is in the 3D file, and it just feels extremely strong to hold on to. And it's also very lightweight. Actually to the point where I'm thinking about, I think I printed it with like a 40% infill density already, so it's pretty solid 3D printed. But I'm actually thinking about bumping it up even more, because I just have the freedom to do so, I guess, you know, just to ensure the strength of the component. But it's already strong enough, I think. So those are just some really cool experiments to kind of showcase what these softwares are capable of, and how you can really like use 3D printing in a very different way to what people have been used to in the past. And I can also then cheaply produce things at a very, very, very efficient way, and also make them look very unique. I don't think there's like a lot of car components that, or car companies that have components that look like that. Of course, we have like Singer. The 21C is an amazing car. I love that thing a lot, and I've been studying what those guys have been doing ever since the first Dassault systems. I think it was, no, the Divergent 3D, I think it was. So yeah, I've been knowing about the technology a whole while, but it's also very fun for me to kind of experiment with it, and also incorporate it with mixed 3D printing, and also making like loose components that are kind of detachable from it, you know, that you can make like ball joints surrounding it, combined with this AI optimized design form, you know. So it's I get to do like a lot of experimentation and just fun engineering stuff that is just, yeah, a lot of fun to me, you know. So that's good what I'm gonna leave you with. Thank you for watching. If you're into this content and just as nerdy as I am, please also make sure to subscribe to this YouTube channel, I should say. We have a bunch more of these videos coming, and yeah, in the next few weeks we'll have the car driving too. So we have a lot of exciting moments still coming for the next few weeks. And yeah, thank you for watching. My name is Veldboom. See you soon.